Hi, my name is Shahriar Shahramian, and it is my pleasure here to talk to you a little bit about our latest work here at Nokia Bell Labs, which is an all-silicon E-band backhaul-on-glass frequency division duplex module with 24 dBm of PSAT and 8 dB noise figure. I've been with Nokia Bell Labs since 2009, and I'm currently the director of the millimeter wave and near terahertz ASICs and systems research lab here. I'm a Bell Labs fellow, and I've also won the IEEE MTT Young Engineer Award. I also teach as an adjunct professor at Columbia University. Our group has won several Best Paper Awards at various conferences, including RFIC and ISSCC. I'm also the host and the founder of the Signal Path video educational series. So enough about me. I think coming out of the pandemic, we can all appreciate the extraordinary important role our communication infrastructure has played in the past few years. Without it, we would not have been able to do a lot of the remote work we've been enjoying. And I believe that even 10 years ago, the exact same pandemic would have absolutely crippled us because we would not have been able to get the data that we expect from our network. Now, one of the ways this network is strained is through our fiber and backhaul links, because as we improve 4G and 5G, we still have to pipe out that data somewhere, and our backhaul and fiber networks have to handle that. So we've been pushing the capacity of backhaul in exactly the same way, going to higher and higher frequencies, and of course E-band and then finally D-band is part of that story. At the same time, a lot of people don't recognize how difficult it is to make a backhaul system commercially viable. They have very strict cost requirements and very strict FCC and ETSI requirements. So you need to make something that is not only performance metrics are very high, it also has to be inexpensive and mass deployable. And we set out to solve this problem by creating the world's first backhaul-on-glass FDD module from the ground up. This module right over here includes our own RFICs. These are transceivers at E-band, which are fully integrated, have up and down conversion, of course, as well as frequency multiplication, LO management, and analog baseband. And they're all digitally controlled and can be calibrated and self-tested. We also created power amplifiers, also in silicon, which we can do power combining directly on glass. Now, one of the really nice things about this module is that it is fully self-contained. It includes the diplexer, which has very strict requirements also, PA power combining, DPD training paths, various filters and interfaces. Essentially, this is a complete backhaul module radio. So once you put this on a printed circuit board, you don't have to worry about any E-band signals being handled by any other material or medium except for the glass itself. At the back of this module is a waveguide interface, and we can connect this directly to a dish antenna. And we did a lot of tests with this. We put it on a PCB and connected a horn antenna in the back and various waveguide components to completely characterize the system, measure noise figure, output power, and we put it through some strict constellation requirements. To the best of our knowledge, this is one of the very first time that such high-order constellations and E-band with such a low EVM have been measured at these output powers. Now, backhaul is a dynamic constellation system, so you have to measure the constellation performance across a lot of output power as weather conditions constantly change the output power and constellation requirements. Now, we've done extensive testing on this. As you can see, we can do EVMs as low as 1.9% for signals as 1024 QAM, and we can go all the way up to 23 or 24 dBm output power once you're using this in QPSK. Now, we're going to do a live demo of this at the RFIC conference, which we're really excited about, showing a bidirectional FDD link so people can see this live actually taking place. It's going to be exciting, and I look forward to seeing you all there.